Hi, this is Mrs. Miller, and today we're going to review calculating slope using the slope formula, using a graph, and a special shortcut. Many of you are familiar with the slope formula. M, or slope, is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. These subscripts are not the same as superscript. So this is not saying y squared. This is saying the second y and the first y. This is the second x and the first x. So let's try to find slope given 2 points using the formula. If we want to find the slope between 1, 2 and 3, 5, we simply plug into this formula. Here we are. This would be our x sub 1 and our x sub 2, our y sub 1 and y sub 2. Okay, so we would simply plug those into the formula and the corresponding places. We would substitute. Here you see 5 minus 2 and then 3 minus 1, which simplifies to 3 over 2. What happens in special cases where there is a negative sign on one of the coordinates? This minus sign and this minus sign are a part of the formula because we are finding the difference in the x coordinates and the y coordinates. So here we are again, x sub 1 and y sub 1, x subscript 2 and y subscript 2. Again, those are just used to help us keep track. We would fill in negative 1 minus 1 for the difference in y, and then 7 minus negative 1. Well, what happens there is that we wind up adding, of course. Remember that from many younger grades. So negative 2 over 7 plus 1 is negative 2 over 8, which reduces to negative 1 over 4. Okay? Now, what if we do this same example using a little bit of a shortcut? Let's find the slope given those same 2 points we just used, except this time we're going to do it in 3 easy steps. I call those steps stack, subtract, and bring y back. Then, of course, you'll simplify as needed. So here's my same coordinates as the one we just did last. We're going to stack our x's and y's. All right, all I did was stack the 2 coordinate pairs. Draw a line down the middle to separate the x's and y's. Now I'm simply going to subtract. I'm going to subtract 1 minus negative 1, which is 2. And then negative 1 minus 7, which is negative 8. Again, now we're going to bring y back. All right, so we have, again, y is going to go on top because the rise goes on top. And I have that little graphic there to remind you. So we're going to take the y difference, which is 2, and put it over the x difference, which is negative 8. And we will still get the same simplified fraction of negative 1 over 4 as we got doing it the other way. This is just another way to think about it and keep it straight in your head. Stack, subtract, and bring y back. And finally, we can find the slope given 2 points using a graph. To do so, we have to just remember again that we're just looking for the change in y over the change in x. So we want to know between our 2 points, how much vertical change there is compared to how much horizontal change. We're going to drop a vertical change line and then a horizontal change line. So let's take a look. Here between point A and B, 3, -2, and -3, 4, we would simply, and you can do this with any 2 points, given any 2 points, you put them on the coordinate plane and then you count. So this is 1, 2, 3, 4, 5, 6. So we have a change of 6 vertically down, so -6. And then 1, 2, 3, 4, 5, 6. A change in 6 in the positive x direction. So again, our y goes on top. It's -6 over 6, which is simply -1. We can try it again. In this example, again, here it is. We want to see a vertical change over the horizontal change. And we count it 1, 2, 3, 4 up, which is why you see that +4 here. And then this is 1, 2, 3, 4, 5, 6 to the positive x direction, which is 4 over 6. When you reduce, it is 2 over 3. And again, this is just a similar example of how you would count the rise over the run in order to calculate slope. Again, we've talked about how to calculate slope given 2 points using the formula, a special shortcut, and on a graph. Hope this helps.